Okay, friends, this will be the third video on return to the basics and what to do if you open a Grasshopper window. Set your Rhino to how I've kind of suggested it in the past, just recommended. I have to move my face over here. We won't be doing anything in Rhino. We'll be building everything in Grasshopper, and we're not going to depend on, we will use transformations later, and we will use intersections. We're not going to depend on surfaces or meshes or curves. We're actually going to continue with the vectors as a beginning. So lay down your point to begin. And this can get fairly interesting. We'll make a grid of points fairly fast. And I guess you could come at it from kind of this grid population, which is a very nice tool. And let's see what we can generate from that. So instead of just starting with one point construction and then working it through ranges and series of attributes, I hope that makes sense, because all my script is about what you can do prior to those initial points. Let's start with a series of points to play with. And even though we're not going to have the attributes, we're going to play with manipulating where they go. So you can start with things that are on grids, which are pretty fantastic. Any shape of grid you want, and then pull the points out of out of those grids. So if I pulled radial, I have this wonderful, and I'm just going to go in here to standard and zoom extends all, and take a look at what I have. Well, I have all of these, but if I grab a container and say, okay, the cells are curved, so let's grab curve container for the cells. There's your cells, and they are all independently written, 100 with 5 sets of 20. Now that's interesting data to think about, and I'm going to try and talk about that a bit. And you also have points. You have a lot of points. And another way to get really nice points really quickly is I'm pretty sure you can just grab the math tool and grab, the surface tool and grab the area of these cells. And now you've got all the points within those cells connecting to all the other puts grafted. So this is where data becomes important, and it gets very confusing. But data trees, I don't know how else to describe Grasshopper versus Rhino. Rhino to me would be something that you plant a seed, you grow a tree, it grows apples, you have a field of trees, you have all these apples you have to put in the bushels, and then you collect them every year. But you get displaced from your land, and you're like, oh my gosh, I have to cut down all these trees because the next property doesn't want them, and I have to replant from seeds all these other trees in the place I want. Grasshopper gives you the power to grab one apple seed in one of those apples in one of those trees on those rows in that field, and simply take that apple seed with you for the 100-mile drive to your new property. And wherever you take it, the entire forest follows you. If that analogy makes sense to you, that's the power of it. So when you got control of that point, think of it as an apple seed and everything else follows. So I've got all these points I can move, but let's just do a quick line connection in curves. So I will go in and I'll make a line, which basically says I'm taking all the data of these curves. Now try and understand what's here. You have, and it's hard to see what you have because you have a lot of items and it just lists on and on and on. You're like, oh my gosh. But there's these weird dark bars in there, which means something is happening. And this is where the Param viewer comes in handy. And it's essential when pushing sliders start to understand the data coming out. So what we have here is actually, and what's nice about this is it gives you a visualization of it. You have 5 branches of the tree with 20 apples on each. So whatever you do will affect those 20 apples on whatever you do to these branches. So you can do different things to those different 5 branches, and then these 20 apples would do the same thing relative to those branches. So think of those as rows of desks in a school, and if you move those rows, all those chairs have to move with them. But they don't have to move in the same order, in the same direction, if you're moving the chairs, the rows in different patterns. So that said, that's where you end up getting into these functions of right-clicking and saying, okay, I want to flatten it. That's like cutting down the tree and putting all the apples in a big basket. Grafting is saying, hey, I want each one of these, I want to appreciate that each one of these, so let's flatten it for now. Here we go, cut down the tree and boom, we have 100 apples sitting in a bucket. Now let's right-click and go back to taking the flattening off. Now we have our 5 branches with our 20 apples on each. And then let's graft, which says let's appreciate every little stem feeding every one of those apples. And there you go. You've got 100 stems with 1 apple at the end of each stem. And the data looks different each time you do that. So here we go. 1 stem, 1 apple, 1 stem, 1 apple. And that's with grafting. And that's literally grafting a tree. The other great tool is to look and right-click here and say, hey, he just made a tree analogy. I think I'll draw the tree. And there it is. There's your 5 branches with 20 apples on each one. And actually, each branch gets its own. So if you're actually thinking of how it looked originally, take off the graph, you've got 5 branches with the 20 items on each one. But it's not appreciating those 20 items. It's treating them all as one item in the visualization. And then if I flatten, it's like, what's happening there? I have one tree that has all the apples on it. So that's easy to think about as well. And if you're looking at what's happening in this data when you do that, you have this strange information that if you take a look at the top, you have the indices referencing each one of the objects and then the data path of what's on it. So you have the first path, then, well, this one's just one with 100 items. But if I go back to the flatten, you'll see that now I have a data path that says you've got the item list, and then you've got the item, and then you've got the index, the items, and then you have the data path of how to find it. And that would be like up this branch, down that little area, and onto that apple. So if I go on to grafting, then you'll see now I have an extra path that I have to follow to get to that apple. I hope that analogy makes sense to you. Let's do something geometric with it. We're 6 minutes in, and I've been rambling. Let's go back to the original data coming out from the cells because that's the way it's built. Keep in mind that this works because it's gray, so you can right-click and extract and say, oh, what was there? That happened to be a world XY plane, which means I can go into vectors, go into planes, and say, no, I want the YZ plane. Put the YZ plane in, and now you see the whole thing shifts in that direction. And so that's the way the gain control of things that are giving you info. The size is coming up, extract it, you'll see you have a float number or a decimal number. So that means, okay, I'm going to make a range of something. Let's just see what that number's at. And you can just hover on it and see what the number's at, which happens to be 1. Let's make a float between 0, dot, dot, period, period, 12. 0.00. That will give me a float from 0 to 12.00 that I can play with. So I go on to this area, and you can see that I can change the size of that structure. So now you're starting to think you don't need that little thing. And this will come in handy when you start clustering and making your own specialty nodes that you can get small programs available to you. Extent R is set as 5. Extent Y is set at 20. I could always set those at set them at the same. I'm going to set them both at 12 and watch how the shape changes there. This one spans out, and this one goes to there. And now we've got a matching pattern. It's not as exciting. It's not a square. It's more rectangular. And what we're going to do is take all these points from this data, the centroid. That's why I like area. It finds the area as a number. But what do I care about the numbered area? What do I care about that data? I guess I could use it if I'm programming, but I'm not programming. I'm more concerned with the centroid, which happens to be a point. So I always extract so I know what I'm dealing with. And if it works, then I know I've got it going on. Another trick is realizing you don't have to plug it in every single node. Just because it has a button in doesn't mean you need it. So if we take the data from these points, which are all grafted separately as points, we don't want that. We want to basically, we could graft differently. I'm going to show you the power of grafting these, not grafting them. Let's not graft it, and let's see the data in its groups. And if you can't see from that thing, let's go back to the Param viewer and say, okay, the data. And I know this can be abstract to start, but it's very important to start to understand if you're going to make your programs run. You've got 12 branches with 12 items in each. So those are 12 things that will line up with, look at these things. These are 56 items with 12 items in each as they go all the way around. 56 total. So you got to divide 156 by 12, and you'll find out how many branches there are. But you can do that as well with the Param viewer. You've got 13 branches with 12 items on each. So 13 branches with 12 items in each could work. I want to show you something that's very nice as I try to draw lines between these. I don't want to match this list of lists of 12 branches with 13 branches, because watch what happens if I do that. And boom, I'm left with this. And you're like, well, that looks kind of cool. That matched them all, but what's happening at the end? Well, that's just got one extra branch. And so you look in here and you're like, I got to control the data. I have to get back in here and minus one branch. Otherwise, I'm going to be in trouble. And you've got all these lovely 0, branches all the way through in the first set. Then you've got all these strange numbers that come out of each set because they're coordinates of those points. But there's something happening with those final points over there. And I don't like them. And I'm going to show you one little thing to start playing with data to control geometries to make things perfect. And this is more complex than any basics of basics, but you're basically, having points and making lines. We're at almost 10 minutes. So what I'm going to do is I'm going to go into sets, and I'm going to go call, actually I think I'm going to go into sequence and do call index. Index is basically this number that notifies you what point that is. And since we've got all these points here and we run down and they're all being grafted into they're grouped into their own sections. They're not grafted, but that's the way they come out. Index number is always something that maybe I don't need the first index number in each one. Maybe I don't need the last index number in each one. If you're saying, well, how do I get to those index numbers? This is where sets and lists is so important. List item, I could go in here and take those points, put it in here and say, okay, I had 13 sets of 12. Let's make an index item that has an index. I can go, well, I can go up to 100 with this script, but let's say, what is there's the item, there's the bar that's actually the one I want to consider being extra. But that's not really the data I want. That's actually a row with all these points on it. I want to show you another great tool to think about. I know this is abstract and difficult. You can flip that matrix from rows and columns. And if you do that and put it in, you're going to notice you're going to end up with all these points pointed right there. List item 1 is right there. So if I go, 13 is there. And then you see how they range out as I go. Now that was kind of hard to see, but 0 as I go here, I've got to zoom in, and if you zoom in on a number slider, you have a lot more control over it. There's data 1, 2, 3, 4, all the way up. You see it go out to 13, but 13 goes back to 0. So basically, we need to get rid of one of these datas, and I'm going to say let's call out data 0 or call out data 13, and if 0 is going to be the one I want, you can always take that and internalize it. Now that has set that index number to 0, and I've called it out, and my list that once was there as points has now had its first item removed. And what I'm going to do is take that list and plug it in here. And now when I put them together, you'll see you get a totally different line pattern of what's happening. Not only that, I flipped the matrix away from going side to side. I've managed to put the lines in this way. And you're like, well, I already had those lines. But in having them separate now, and this is where, it does get wild. I'm reading this data all the time. I can take those separate lines of what was a program, literally a program. I came in and I grabbed a radial array. And now I'm able to take those lines, go into my sets, and take a look at list length and say, how many items do I have there? 12. Let's pull it in here. I have 12 items on 12 different branches, which means I can take that number and I can move this, and this is where I'll get into transformations, which is this lovely little squiggly, jumpy little springing bird, let's say. Let's just move those, and let's move those geometries, all 12 of them. And now it's all moving them to a default to 10 in the Z direction. But I want to move in the X direction. And I want to move in the X direction differently. So I want to move with a range. I'll show you here, range in, and I want to move from a domain, and this is how you get into this, building ranges and domains, and I want to move between 1 unit and 12 units. So I set that as the highest point of the range and the lowest point of the range. This is pretty mathematical. The steps need to match the number here, and since I've already brought it down by 1, I can actually plug it directly in. It's grafted, plug it in here, and what happens, I've now moved all those geometries all the way up in different ranges. So if I make that, now I'm dealing with geometries that I can lengthen like a staircase. And in lengthening the staircase, I could easily find, well, I'm actually not going to offset. I'm just going to take my curves that are here, leave it as the data that's coming out, and I've got to wrap this up in a matter of minutes, so I had to splice the thing. I've got geometries coming out. What do I have? I have a whole bunch of geometries that I've moved. How many are there total? Put on the Param viewer and take a look at what you have. I didn't mean to put my transform in there. I meant to put that in there. Basically, I have all these lines. What I have is 12 branches of 13 lines running up this way and running up that way, and I can loft them together as they go up. So that's basically what I did, was I grabbed them, and now I have a loft of 12 items with 1 item on each, and I made this kind of slippy, slidey chair. Now, I all made that because of what I was dealing with. Now, if I go back parametrically to my very first structure and say, okay, the cells do not have to be those cells. Let's hurry up and fly. Let's go into hexagon cells. It's going to be for a crash program, I imagine. Control-Shift will take this out and put it here. This one will take it here. And we end up with a totally different kind of planar system. It doesn't work because it's not radial. Maybe I shouldn't have done that. I think I'll just leave it with what it is. So sometimes you do things and you're like, oh, what's that going to do? That geometry is built on that other one. At least we can show how parametric it is by sliding this and stays functional to what you want to do. So build your geometries this way, offset them, have some fun, change the angles. Thanks for watching, Aaron and others. That's how I think, and that's how I make, and that's how I'm creative.